It would be a good idea you decide to drive your car really fast over a hill with the goal of catching air or getting your car to leave the ground. Not a very good idea, but for some reason some people like to do it. So can we figure out how fast you'd have to go on this particular hill or any particular hill to know how fast you would need to be traveling in order for your tires to lose contact with the ground and your car to become airborne? Well, if your car becomes airborne, that means that there's no longer a normal force acting on your car because we're looking for the moment where your tires would leave the ground, not while your tires are still touching the ground. So how fast do you have to go in order for your tires to leave the ground? Well, at the very top of the hill, then, the only force acting on the car is the force of gravity because your tires have now left the ground. And we know the radius of the hill is 10 meters. So now what we need to do is say, okay, what force is acting as our centripetal force, the force allowing this car to continue along its circular path? Well, there's only one force acting on it, and that's pointing down towards the center of the circle, and that's the force of gravity. So that is our centripetal force when we go so fast as to eliminate the normal force from the equation. So now force of gravity is mg, centripetal force is mv squared over r. Now, why did I choose this version for centripetal force? It's because I have the r, and velocity is what I'm looking for. So that's why I chose that version of the equation. What's really nice is mass will cancel out, which means that it doesn't matter if you're driving a big truck, or if you're riding a bicycle, or a motorcycle, or a smart car, or whatever. If you hit the speed that we're about to find, you will go airborne over this hill. Doesn't matter how massive your vehicle is, because mass is irrelevant. So now we're going to solve for the velocity. I just have to multiply r over, and I get gr on the right side equals v squared, but I don't want v squared, so I take the square root of that left side. So it's the square root of 9.8 meters per second squared times the radius of the hill was 10. And when I plug into my calculator, I find that the magic speed for this particular hill is 9.8 meters per second for speed. If you go that speed or faster, your car will become airborne. Any slower than that, and your car will not lose contact